In this Excel demonstration, we're going to talk about testing the difference between two means of independent samples. So in this demonstration, we're going to talk about the z-test. So the Excel demonstration that you'd want to bring up as far as the workbook is concerned is Excel demonstration store A and B z-test. So here's our scenario. So what you want to keep in mind when we're using Excel to work with these hypothesis tests is it's going to give us the test statistic or the p-value in order for us to make our decision about the hypothesis test. You still have to set everything up on paper. You still have to do your null hypothesis and your alternate hypothesis and do all of the setup, but you're going to use Excel to find either the p-value if you're doing the p-value approach or the test statistic if you're doing the traditional method. So here's the first scenario. Test the claim that the two population means are equal using the sample data provided here at alpha equals 5%. Assume the population variances are sigma squared of store A is $4.10 and sigma squared of store B is $6.75. So in this one's case, we're doing a z-test. And the variances are known. They're giving us those variances. So those are the population variances that somebody has calculated and given to us. So the first thing that we want to do is let's explore where we're going to find these Excel functions at. They're under the data analysis tool pack. Over here, data analysis, and then down at the very bottom. So when you scroll to the very bottom, there's 4 tests that we're going to be doing. So the very bottom one, alphabetically obviously, is z-test to sample for means. And we'll click OK. Variable range 1. So our very first variable is going to go in this first location. So we're going to highlight everything. I'm coming all the way down, all 30 pieces of our data that we've used. And then our variable 2 range, so we're going to come over here to the second one. And it doesn't matter, remember, whether you highlight from down to up or up to down as far as getting your range of data. So come all the way up here. Hypothesize mean difference. So for all of these, we're always going to say there's no difference. That's going to be for every single one of these tests as far as the z-test or the t-test. So let's say 0. The variable 1, it says variable 1 variance known, and that was what they gave us, and we're going to say 4.10. Variance 2, so that was $6.75. Our alpha was given in the problem. I'll scoot this down so we can see it. So alpha is 5%. Alpha says 0.05. So you have 2 choices. You can either put the output in a new worksheet, or you can choose a location to put it on this worksheet. So I'm going to say output range, and then I'm going to come over here and I'm just going to click this location right here. So that's where our output is going to come, is going to be placed. So let's click OK. And here's our results from the z-test 2 samples for means. So it gives us some information at the beginning, but the things that we want to pick up. And so the information that we want to glean from this output from this test is this is your test statistic. That's your z-score or your z-value that's associated with our test statistic. This is the p-value if, let me make this a little bigger so that we can see it, so we can see what these labels say. And so the very first one, this is your p-value if you're doing a one-tailed test. this down here, oops, this one right here is your p-value if you're doing a two-tailed test. So this is the information that you want to use to make your conclusion on this hypothesis test. You want to use Z. Let's highlight it. The p-value, so Z is if you're doing the traditional method. The p-value for a one-tailed test. Went too far on that, so let me do no fill on this bottom one. Or the p-value for the two-tailed test. So those are the three pieces of data to pick up off of the output when you're using the data analysis tool pack and running these calculations using Excel. The next one that we want to talk about is, let's do the Z-test variances unknown. So notice I have another worksheet down on the bottom, so you want to click on that worksheet, and we're going to do the Z-test if we don't know the variances. So now what happens if the population variances are not known, but N is greater than or equal to 30 for both samples, and our N is exactly 30 in our samples? Use our formula from Excel, var.s, or var if you're using an older Excel version. So I'm going to come all the way down here to the bottom, and we're going to calculate our variances instead because our variances aren't given. So coming all the way down here, I'm going to say equal var dot s, and remember that's the same equivalent as just the var command. I'm going to highlight these all the way up, so my whole entire range. Enter. $4.21. Then I'm going to go over here and I'm going to do exactly the same thing. So it's exactly the same command, so we can copy that command over, copy the formula from here to here. $6.97 as far as the variance for our population, for our 30 pieces of data for store B. So now let's run our calculation again, and we're going to use those. So those are going to be the values that we use when we do our test. So going to data, data analysis, all the way down to the bottom, the Z-test. Okay. So there's variable 1. It was okay. We're not going to touch that. Here's variable 2. We're highlighted again from C6 to C35. We're hypothesizing that there's no difference between these two sets of data. The variable, so here's our variable 1. So now what we're going to do is we're going to put these two values in. So I'm going to backspace this out, and I'm going to put our variances in from our table over here. So for the variance for store A, we're going to type in the variance that we calculated. So we'll say 208. I'll go ahead and put all of the values in without rounding. And then on this bottom one, we'll put 6.966337. Then the output range again, so let's decide where we're going to put that. So let's just decide, the alpha again is 5%. I'm going to place it right here in my Excel worksheet. I'm going to calculate OK, and then we can look at the information that Excel gave us. So let's make this a little bit bigger, And we'll pick up our test statistic here again. So our test statistic is 0.935041. I'll highlight it. Then the p-value if we're doing a one-tailed test, and then the p-value if we're doing a two-tailed test. So here's the output. So the Excel demonstration dealt with a z-test if the variance was known and given to you in the problem, a z-test if the variance is unknown and you have to use the sample variance as long as your n is greater than or equal to 30 for both samples.